Alright, let's look at this second example of higher order differentiation. Alright, higher order differentiation. So, okay, let's say I change this question become fx, right? Fx. So, if you want to differentiate this for the first order differentiate, so f prime x. So this will be, I will applying uv, right? The quotient rule. In this case, I will apply quotient rule, as quotient rule will help me because this is a, can you see there's two term here, right? So I cannot divide directly, so I have to apply quotient rule, and this is not a product form, right? It's a u divided by v. So I'm going to apply the quotient rule. So let's say you have u to be x squared and your v to be 2x plus 1, right? So then you have u prime, differentiate x squared, you have 2x. Differentiate v prime, differentiate, so you have 2, right? So then you apply the quotient rule. So which will be your v u prime minus u v prime over v squared. Alright, v u prime minus u v prime over v squared. So v 2x plus 1. 2x plus 1, u prime, your u prime will be 2x, minus with u, u from there will be x to the power of 2, and your v prime is 2, right? 2. So remember the order, v u prime minus u v prime, so divided by v squared, so you will have 2x plus 1 to the power of 2, right? So this is your first order differentiate. So you are getting 2x and 2x, you will have 4x squared. You have 4x to the power of 2 plus with 2x minus with 2x squared divided by 2x plus 1 to the power of 2. So this is a first order differentiation. So I further simplify this. I will getting 4x to the power of 2, 4x to the power of 2 minus 2x to the power of 2. You have 2, right? You have 2x to the power of 2 plus with 2x divided by 2x plus 1 to the power of 2, right? So you are getting this. This will be your first order differentiation, right? So let's say if I want to differentiate this one again, it will be a second order, right? It will be a second order differentiation. So let's see how to do. Alright, let's go for second order. So second order will be f double prime x, but you are still applying the uv, right? Uv. So how to do it? Alright, so means that your u, so u will be 2x squared plus 2x, right? 2x squared plus 2x. So your v will be 2x plus 1 to the power of 2, right? You apply the quotient rule again as you using this function and you differentiate again, right? It's still a quotient. So you u prime differentiate du dx, you have 4x plus with 2, right? 4x plus with 2. And v prime will be 2x plus 1, right? 2 power rule, 2x plus 1, 2 minus 1, you have 1. Differentiate 2x plus 1, so you have 2. So your v prime will be 4, right? If you see carefully, this one will be your 2, 2, 4, right? 2 times 2, 4. So 4, 2x plus 1. So your v prime will be 4, 2, 8x plus with 4. Finally, you have this. So your 4x plus 2 and your v prime to be 8x plus 4. So then you have all this information. You can apply the quotient rule again, which will be v u prime minus u v prime over v to the power of 2. Alright, this is a second order differentiation. So what is your v? Your v in this case now will be 2x plus 1 to the power of 2. U prime, your u prime will be 4x plus 2 minus with u. Your u is 2x squared plus 2x squared plus 2x. Your u v prime, so v prime is 8x plus 4, right? 8x plus 4. Everything divided by v square, so 2x plus 1 square, and square again, which should be give you 4, right? You're getting square and square again, you're getting power of 4. Alright, so okay, it's possible for you to simplify this, as you can see that this is 4x plus 2, right? 4x plus 2, so 4x plus 2 and 8x plus 4. So you can take out, okay, I can simplify for you. You can see, as you know that 4x plus 2 is 2 times 2x plus 1, right? 2 times 2x plus 1. So then you are getting 2x square, then you have 2 times 2x plus 1, right? 4x plus 2 I can rewrite as 2x plus 1, 2 here, isn't it? So minus, and this one I think cannot be further simplified, so I just leave it 2x, but 8x plus 4 can become 2x plus 1, but I factor out the 4 here, right? Because 4, 2, 8, 4, 4, 4. So, alright, so now it's time for me to factor out the common factor. Factorize out the common factor. So, okay, you have 2x plus 1. Here you also have 2x plus 1, right? You have 2x plus 1. So this one actually can combine, become 2x power 3, but doesn't matter because I want to take out the 2x plus 1. And the 4 and the 2, I take out the 2. So I take out the 2. Then inside, I taken out the 2x plus 1. 2x plus 1. So, okay, let's say what is the remaining factor inside there? You have taken the 2 and 2x plus 1, right? So you have 2x plus 1 to the power of 2 here, right? So negative 4, you have taken 2, factorize the 2 out, so you still have 2. You still have 2 inside there. And 2x plus 1 is also already taken out. So inside you still have 2x power of 2 plus with 2x. So divided by 2x plus 1 to the power of 4. So now you see that this one and this one actually can be simplified, right? This 4, this is power of 1. So you can cancel out 4 minus 1, you're getting power of 3. So means that 2 over with 2x plus 1 to the power of 3. Why become 3? Because from index law, 4 minus 1, you're getting 3. So, okay, let's simplify this. So this one you will have 4x squared. You expand 4x squared plus with 4x plus 1 minus with 4x squared. You can see that it's even more simplified after you simplify 4. 2, 4x squared. Negative 2 times 2, 4x squared. Negative 4x squared, negative 4x, right? Negative 4x. So as you simplify, you are getting this whole thing, 4x squared and 4x squared cancel out. And 4x and 4x cancel out, right? You see that 4x squared minus 4x squared, you are getting 0, right? You are getting 0. And 4x minus 4x, you are also getting 0. So you still have 1. Finally, you have this form. You will get your answer to be 2 over with 2x plus 1 to the power of 3. Right? 2 over 2x plus 1 to the power of 3. Okay, let's continue. Differentiate for third order. Alright, this is the second order which you're getting this form, right? So now we have third order. We are finding for third order differentiation. Means that triple prime. So third order. So we will try to differentiate this one more time, right? So if you see carefully that your second order here, after you differentiate, for so hard, so many things to do, so you can rewrite this as 2x plus 3, 2x plus 1, okay, 2x plus 1, 2x plus 1, if you bring this go up, the bracket, the power will changing, become power of negative 3, right? So means that your f prime x is, okay, I rewrite here, your f double prime x, the second order derivative, you're getting 2x plus 1 to the power of -3, right? So okay, now continue. We differentiate. Okay, we differentiate this one, this function. So 2x plus 1 to the power of -3. So what to do? So you have to bring the -3, apply the chain rule, right? The chain rule. So just now you apply quotient rule first time, right? First order derivative, you apply quotient rule. Second order, you apply quotient rule. Suddenly for this, do you need quotient rule? Yes, you want to apply, it's okay, right? This is still u and v, but this is a constant, right? So we can, using chain rule even faster. So we can differentiate this one, 2x plus 1 to the power of -3 by bringing the power. So -3 times with 2, you have -6, right? -3 times with 2, you have -6. So then you copy back, salin balik, and -3, you minus 1, you -4. But it's not finished yet because you apply chain rule. So the function inside there, you also must be differentiate. Differentiate 2x, you will have 2, right? Differentiate 2x, you will have 2, right? So, okay, then you're getting -6 times 2, you have 12, right? -6 times 2, you have 12, over with 2x plus 1 to the power of 4. This one become your third derivative, right? If you want to go for fourth derivative here, so how to write? Alright, let's say you want to go for fourth derivative. So okay, the fourth derivative will be so f prime 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 x, right? Not if 5, then there's so many prime, right? It's very untidy, right? So what you do is you can rewrite this one to be f, but you put the bracket 4x. This is the meaning of you differentiate this for the fourth time. After 3, you can write 4. If you derive this for the 5th time, you will write 5, right? Or you can write this one. Actually, this one is y prime 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 prime, right? Or you can just write as y bracket 4 to show that this is actually fourth order derivative here. So okay, let's derive this one again. Again, you apply. You have rewrite this one to be -12, 2x plus 1, -12, 2x plus 1 to the power of -4, right? Apply the power rule again because this is a constant also, right? So -4 times with -12, -4 times with -12, you have 48, right? 48 and 2x plus 1. Then the -4, you minus 1, you have -5. Differentiate the inside one, you're getting 2. So you get 96 over with 2x plus 1 to the power of 5. This one will be your fourth order. So it will be not finished. It will keep continue. So I just want to show you that what is the meaning of higher order differentiation. So hope you study this video and you know that the meaning of higher order differentiation.